if you need to speak with her. All right, so without further ado, I'd like to turn this time to Dr. Julie Patrick. Dr. Patrick is a professor of psychology, and she has done numerous workshops on SPSS to help beginners. And I have muted everybody just so that she could concentrate on, not to have to hear noise in the background. But when you need to ask a question, go ahead and unmute yourself, and I'm sure Julie would welcome your questions. Julie.
Thank you. I'm so excited to be here. I appreciate Dr. May inviting me, and I'm so glad to see so many people here. So what I'm going to do is talk a little bit today about SPSS.
Hello.
Hi. Welcome.
Hi, my name is Ganga Nakarmi. Thank you. I'm sorry I was a little late because I was trying to fix the computer and it asked me password and everything, and I forgot that. I have to look for that. I'm sorry about that.
That's right. Thanks for being here. No, we're just getting started, so thanks for being here.
Thank you.
So as we go through, if you've got a question that you want to ask immediately, certainly unmute yourself and ask, but recognize that, I'll probably lose my train of thought and have to start over a little bit. Or you can write it in the little chat. And as we get to the end of a section, because I tend to talk kind of quickly, I'll go ahead and go to the chat and pull some of those questions. I know sometimes people don't like to talk over Zoom, or they don't want to be seen over Zoom. So however you're here, I'm glad you're here. I also want you to realize that this really is an introduction. And so there may be more intermediate or even more advanced topics that you're really interested in that we're probably not going to get to today. I've left my email on the last slide. Of course, you can also just look me up in the WVU directory as Julie Patrick. And I'll be happy to hop on a Zoom call with you or to answer your question via email. So feel free to continue to use me as a resource beyond today. All right. And here's my true confession. I was on sabbatical in the spring, and so this is my first Zoom lecture. So there may be a little bump here and there. So I do have a schedule, and for those of you who are here at 1 o'clock, thank you. But I recognize that some people may be just popping on and off at different times. That's fine. If we get into something and you see that you already know this and you want to pop off for 15 or 20 minutes and then come back in, you're totally welcome to do that. We're all really busy, and we're all sort of a little Zoom overwhelmed. So I want to respect that aspect of the decisions you make. But here's basically what we'll be doing. A few minutes on the introduction, a few minutes on file management, a bit on descriptive statistics. I'll talk about recoding variables and data transformations in SPSS, and then we'll do some very simple inferential stats. And I tried to leave some time at the end so that you can ask questions either about what we've talked about or things we haven't gotten to. In the chat, there are 2 links. So if you would like a link to a data file that we'll be using as an example, you can go, and you've got SPSS installed, you can just download that data file and work through the exercise. Or you can download SPSS and you can do it from scratch, and we'll do it together. So wherever your expertise is, if you've entered data and you've done all that and you don't need to do it from scratch, download the data file and we'll run things together. If you want the experience of entering data and those kinds of skills, we'll use this time to do that. It's built into the lecture. All right, so SPSS and Excel and R and BMDP and there's just a host of programs that are really nothing more than tools to help you detect patterns in your data and to analyze those patterns using statistics or graphical representations. Some people get really attached to the program they use, like, oh, SPSS is just drop-down menus, and if you're a real scholar, you'll use R. Well, R is great if you're an advanced statistical scholar. But if it's hard to start with R because you have to write in code, and a lot of us just don't have those skills yet. If you eventually want to move to an inexpensive program like R, using Excel or using SPSS to sort of learn some of that language is really helpful. It'll make that learning curve a little easier. There's also disciplinary differences. Like engineers love Excel. It does most of what they need it to do. And so they don't use statistical package for the social sciences. They can do programming in Excel or R. So just so that you know, sometimes people get those, they really get tied to the status of struggling through writing your own code in R versus knowing how to do some of the fun equations in Excel. I tend not to buy into that. It's just a tool, and I can't get excited over, a Matco tool versus, a Snap-on tool. They're just tools in different companies, and that's how I view these statistical programs too. They do have different strengths and different weaknesses. SPSS can be pricey. There's a student version, a full student version, that I think through the university you guys can get for somewhere between $65 and $90, but you can only get it that way for a year. You have to renew the license every year. Excel comes embedded in Microsoft Office suite, and so that feels more affordable, especially since you've got 5 free downloads of Microsoft Office through the university. And then R is open source code, and there's a whole community that shares the code for this is all the code that you need to run a t-test or hierarchical linear regression. So those there is that community out there. Okay. So today we're going to work through some data examples, really from the soup to nuts kind of approach. And I wanted to start with just a couple of questions that a person might put in Qualtrics. Now, you wouldn't actually use this in Qualtrics, but if you haven't seen a Qualtrics survey, this is how it might look. It might look this way in the PDF form and this way on your cell phone. All of you as WVU members can access Qualtrics for free. You have to request the account, but it's part of what you have. So you can go to IT and you can look for the Qualtrics link and then request your own account. And so that's nice. If you're paying the $160 or $180 a year for SurveyMonkey, Qualtrics is free for you right now. So you might think of doing your theses and dissertations and other projects in Qualtrics. So surveys in Qualtrics, you can get data in a couple of different forms. And here on the screen you see that the first one is using numbers. What is your age? And ideally the person will type in the number of years they have in their life. And so it's just an open text box. The next question is a multiple choice. So regarding gender, are you male, female, or non-binary? The numbers that you see, the 1, 2, and 3, are numbers that aren't shown to you or to a participant, but they're on the back end of Qualtrics. And so when a person selects male in this survey, Qualtrics will enter a 1 in the data sheet that you can download. The first option you list is 1, the second is 2, the third is 3. You can go in and you can change those values if you like, but you have to know that you can do that. The third little question here on the screen at this little section, you can ask questions in a table. If you've got a slew of questions that come from the same scale that go from agree to disagree, you can enter them in a table and people can then just hit that radio button for their response. But again, it's going to be labeled 1, 2, and 3 depending on the way that you've labeled those columns. So when you download a data set from Qualtrics, all your agrees in this question are going to be 1s, all your neutrals are 2, and all your disagrees are 3s. We'll come back to why that might matter. But if in the back of your head you say, oh, I can change those values at the level of Qualtrics, or I can change them at the level of SPSS, we'll be good to go. So for those of you who are following along, If you've downloaded SPSS, you'll probably see an icon like this on your desktop, or you can go to the programs list and go IBM to SPSS, and that's the way you can launch SPSS. So either from an icon on the desktop or through the programs list. It's, for me, I actually like just having the icon because I've been messing with SPSS for a long time. I just like to not have to think about where it might be. But you guys may prefer having a cleaner desktop than I do. So if we can imagine that you've set up a survey in Qualtrics and you've asked a bunch of people, let's say 5 people, those questions about their age, their sex, and whether they like science and what they think about research. Qualtrics will load that into an Excel sheet, and you can download that Excel sheet from Qualtrics. If you want to bring that Excel sheet up into SPSS, you can do it really easily from a blank SPSS shell. So you just launch SPSS. It'll open into a blank document, and then you'll just go File, Import Data, Excel. And it will open up this kind of file menu where you can specify the name of the Excel sheet, and SPS then is ready to process those data. Couple of things, I know there's a lot on the screen, couple of things I just want to point out to you. You do want to be careful what file you're uploading because you may have a lot of Excel files. So that's sort of your first check that you're doing it correctly. But then you also want to check this options link where you can ask SPSS to take the first row of your Excel sheet and use those for the names of the variables. So that's kind of nice, unless. So this is an actual snapshot of a Excel sheet that we use for some data. And you can see that we've got response ID on row 1, DAT response ID, and then a variable name response ID. In this column J, we have Q111, and then the question is, in which month were you born? At that upload screen, if you said take the first name or the first line as the variable names, this question is going to come in as Q111, which is fine. But you might want to have the second row be the names of your variables. And so you have to think a little bit about what is it that you want to bring into SPSS. I'm going to see if I can, I don't know that I can get your question. I don't know that I can get your question from here. Oh, maybe I can. As I said, it's my first time.
I just raised my hand, Julie, if you were mentioning me.
Yes, I am. Yeah, I don't know that I can call on you. Yeah, and I didn't want to mispronounce your name if I'm sharing the screen.
I was thinking you're looking for another one. Is there any specific version that you're working on, the SPSS?
I'm using the latest, so I believe that's version 26.
Okay, because my menus are a little bit different. I'm a very beginner in SPSS, and I was wondering if it's different version. It's all right.
And what version are you working with?
It's 26.2.
Okay, well, this is what's on the screen right now is an Excel sheet. So that maybe
the previous window that you showed, it's all right. I just wanted to make sure.
Okay.
Yeah, I didn't see this window on the right side when I clicked on the Excel.
Oh, all right. Thank you.
All right, thanks.
Okay. Okay, so you do want to be careful whether you have that box clicked to use the first row as the name of the variables. If you want the second row, what you're going to have to do is clean your Excel sheet, and you're going to have to delete that first row so that SPSS can read the words in which month were you born instead of Q111. Okay. So when we think about SPSS and sort of creating the file from which we're going to use, there's a couple of issues, not just in importing the Excel sheet, but also in labeling the variables, specifying their values, and naming the files. And so I just want to, you know, sort of in good practice, mention some of these to you. And we'll do that in the context of manual data entry. If you're working through the SPSS, you know, problem, if you've got SPSS open, and if your screen doesn't look like this, you might go File New or File Data New, and you should get an empty worksheet. But it might look like a column with numbers on the left, and it might say var for variable. Or you could have those numbers on the far left, and it might say things like name, type, width, and decimals. Depending on which you see as that top row, that's going to indicate to you whether you're in the data view or the variable view. And so we do different processes from data view windows versus variable view windows. And so if you're following along, I'd like you to go ahead and click the variable view so that your data file in front of you says the name, type, width, etc. And the reason that I'd like you to do that is SPSS is like a relational database. And so we can interact with it a couple of different ways. For most analyses that you'll do, each row of your SPSS file will be a person or an observation. And each column in SPSS is generally a variable. So if we're in the variable view, we can tell SPSS what those variables are, what kind of data they are by variable type. And then these things like width is just literally how wide that column is on your screen. Whether you want 1 decimal place, 10 decimal places. And so this is really where we're going to describe the data to SPSS. So some naming rules and conventions in SPSS. SPSS will not allow you to start a variable name with a number. So it has to start with a letter. SPSS also will not allow spaces in a variable name. You can have those in labels, but not the variable name. And so you should probably just get in the habit of, you know, not having spaces in the names. If you try to do that, SPSS will send you a warning. Sometimes the warnings are helpful, like you've put a space in the name. And sometimes it just says you violated a rule. And so that's not really helpful. And so no numbers to start variables, no spaces in variable names. And then there are a few words that are commands in SPSS, and you can't use those as variable names. Execute, you know, you're going to execute a process. You can't have a variable named execute. SPSS just can't deal with it, sometimes being a variable name and sometimes being a command. All right, so all that being said, if you're in variable view and you've got that sheet where you've got name, type, width, and decimals, you can just type in the names of the variables that you'd like to use. Then we have that little survey where we ask people their age. We ask whether they were male, female, or non-binary. We didn't ask IQ, but we might have IQ data from another file that we want to bring in here. So we can do that. I think we asked them how many days they were out with their friends. I'm not sure if that was on there or not. And then we've got Q5A and Q5B. And those were the questions like research is hard, agree, neutral, disagree, or I love research, agree, disagree, neutral, disagree. So we can name those variables. All of those are numeric. They're going to be represented in our data file as numbers, but we could represent them as words, like for sex. We could have the file that it just says male. For Q5A and Q5B, ultimately what we're going to analyze are the numbers, but we can also still label those. And so that's what this is here. The values column is where you can tell SPSS that 1 equals agree and 2 equals neutral and 3 equals disagree. And so if you wanted to enter values, you could just take your cursor and click that box and it should open up into this value label screen. And you literally just type that information here and make sure you click add. And when you're done, click OK. and now your variable is labeled. It's sometimes scholars want to be efficient with their time. And so they think, oh, I don't have to label that. I know that this is a 5-point Likert type scale. I'll never forget this. It's pretty quickly in your career, you'll start juggling multiple data sets. You'll start doing recodes. You'll do a whole bunch, and it's easy to forget what the heck is happening. And then you have to go back to the Excel file, if that's what you used, or back to Qualtrics and look at the original survey. This labeling and putting the value labels in now will save you a ton of time down the road. If you've labeled the variables in the variable view file, you could click the little data view tab on the bottom, and now all those variables become names of columns. And so when you look at that data sheet, you should see blank lines and then columns labeled age, sex, IQ, days social, Q5A and Q5B. And so that's part of the reason that you want to spend some time thinking about how to label your variables. You know, Q5A and Q5B are not terribly meaningful. And so you would always have to be looking back, I think. Part of the reason that I like to use them as Q5A, if I were to open a survey, or if I had a copy of my survey, I know that that's question 5A and question 5B. And later I'm going to use those to create some scales. And so I don't really care what the raw variable name is, because I'm not going to use it other than to create a scale. But age and sex and IQ and days underscore social, I'm going to use those variables a lot. So I want them to have really meaningful names. As you move through the data sheet, you can use the tab key to move to a different column, or you can use the arrow key to move to different columns or cells. You can use the hard return that will get you to the next line. And so there's lots of ways to navigate that spreadsheet that is SPSS. I don't know if you can hear, my cat says hello. So if you want experience at manually entering some data, these are the data that we're going to work with today. So in the data view, you could quite literally on line 1 type in age for person 1 is 21. Their sex, I've recoded it already. Their sex is coded as 0. They have an IQ of 110. Number of days per month social, 19. I've forgotten Q5A, that they were a 3, and Q5B, they're also 3. And so you could type those data in so that we could analyze them later. Couple of things that you might notice. Having this kind of a spreadsheet is really kind of nice, because you can look at the data and say, oh, here's this person. For some reason, we don't have their gender recorded. They may have chosen not to share that. They might have hit a button but not hit it hard enough. And so we don't know why that value is missing. We only know that it is missing. So you might be tempted to do something with that, but all you can do is say, we've got data from 5 people, 4 individuals reported their sex, 2 reported being female, 2 reported being male, and 1 person we didn't disclose, or we don't have those data. If you look at the IQ column, this, like most IQ tests, average score of 100, standard deviation of 15. If we had a score of like 181 for IQ, we would probably raise our eyebrows and say, boy, that's out of range. That's kind of unusual. I should go back to this person and see if there was a typo in entering their data. And so you can look at your data and get a sense of whether the values are in the correct range. You could look at days social, and you can see that there's lots of variability. Some folks are spending a lot of time with friends, 25 out of 30, 31 days a month. And other folks are much more modest in their social interactions compared to the high outgoing ones. And so it gives you a feel for your data. You should look at your data just to see that, to sort of start drawing a feel for it. One of my colleagues refers to this as getting cozy with your data, so that you're very comfortable with it. You can look at that age group and you can make some assumptions. This is a pretty young group, maybe a college sample. 21 to 23 is a pretty narrow age range. It would be unusual if any of these variables showed really strong age differences, unless we think there's something really different about ending your sophomore year or starting your junior year and maybe being in a fifth year. So that 21 to 23 is a pretty tight age range. If you're entering these data points by hand right now, make sure that you save that data file, and you'll have to give it a name. You might just call it practice or intro or whatever. If you don't want to enter these data, again, remember there's a link that you can download an SPSS file. So as we work through some of these problems, you can do some of it as well. All right, I'm going to see if there are any questions in the chat or if you all have questions at this point. What's the difference between a variable name and a variable label? That's a great question. Thank you. Variable names are the headers of the columns in an SPSS file. A variable label might be a longer description. So we could have the variable name as Q5A, and the label might be research is hard. And so they're certainly linked to each other, but they're just easier or more difficult to use depending on what you're doing. SPSS will let you flip between the two in tables and in charts and in graphs. And so it's nice to know that you can do that. Thanks for that question. Are there other questions? All right then. Well, if something comes up, feel free to ask it either in the chat or out loud. So we're going to talk a little bit about some basic descriptive statistics. And before we do that, we'll talk a bit about data cleaning. And then we'll just really talk about those first 4 moments of a distribution: central tendencies like means, dispersions like standard deviations, and skew and kurtosis. Sometimes it doesn't like to, there we go. So for data cleaning, depending on how you've collected your data, those errors can show up in a couple of different places. If you're having people key in their own responses in a Qualtrics survey or SurveyMonkey or whatever, sometimes people push the wrong button. And so you have to be able to discern whether someone has pushed the wrong button. And that's where the minimum and maximum come in handy. If you know that you've got a response scale that goes 1 to 5 and somebody's entered 6, well, clearly that's not the right answer. That wasn't an option, so that's a mistake. If they have miskeyed and made a mistake, you can't use those data. You have no idea what they meant. If it's a hard copy kind of survey and you've got questions like research is hard and I love science, if they've circled 2 answers on one line and left the next one blank, you don't know whether they're agreeing or disagreeing that research is hard. And clearly they don't have a response for I love science. So you lose both of those items because of an error. If you're collecting data in person with hard copy surveys, you might actually look through the survey to make sure all the items are answered and there's no double punches, so to speak, because you'd hate to lose both items. Sometimes, depending on how you've collected your data, there can be data entry errors. And like with the IQ, people don't have IQ scores of 181 on most IQ tests, but a score of 118 is certainly reasonable. You can't make the assumption that you know what that error is. You'd have to go back to the record and check it. And sometimes you can't really verify it. If there's an error in the data, you have to delete that data point. You can still use that person. You just don't get to include them in analyses that involve IQ. The biggest source of errors that my lab has been having lately is operator error from me setting up a Qualtrics survey. Qualtrics Qualtrics does some really nifty things, but if you set up a response scale that goes from 1 to 5, for strongly disagree to strongly agree, and then you move to another section of your survey, you can copy so that you don't have to keep typing in all those response scales. So that's awesome. So I just, cut, copy, no problem. But if I get to a point where, well, two things can happen. I can do my 1 to 5 and copy it, and Qualtrics might think of that as a continuation. And so instead of going 1 to 5, now it's 6 to 10. Or if I've copied my 1 to 5 response scale, but my next set of questions has 7 responses, if I insert extra columns, Qualtrics can't quite handle it. It just keeps numbering those. And so you can go from a response scale that's 1, 2, 3, 4, 5 to one that's 8, 9, 10, 11, 15, which is what we actually had. These are some data that we had. And when we ran means, this was a longitudinal study. And the first time we did it right. And so people had average scores of 4. The second time we ran them, just a few weeks later, those scores were like 9. And it was like, oh, we get this changed. And it's like, no, we just coded wrong. You can go back in and correct your coding, but you have to look at your data. It would have been easy to just compute these scales that these are part of and not think that the scoring of the individual items had somehow gotten off. So I can't urge you enough to do data cleaning. My last undergraduate project was collecting data. And then my first graduate project was to actually analyze this data. I went to the same institution. And I spent a whole year doing these data analyses. And then at the end of the project, it was like, oh, I did something wrong way back 6 months ago. And if I had just looked at the data, I wouldn't have wasted a whole year's time. You guys are doing high stakes projects too. So don't cheap out and not do the data cleaning. Definitely spend some time making sure that the data you analyze really are data. Do you guys have questions about data cleaning? We'll give some examples, some more specifics about how you can detect errors and how you can fix them. But okay. So in addition to making sure that the data set with which you're working is clear of errors, you probably should engage in some really good exploratory data analyses before you dive into the fun hypothesis testing things that you've proposed. And so exploratory data analyses is an important part of the research process. We're going to talk briefly about how to trick out central tendency, measures of dispersion, skew, and kurtosis. So if you're working in SPSS right now, you can get some frequencies to look at by going analyze, and then drops down to descriptive statistics, and then over to frequencies. So analyze, descriptive, frequencies. Under the analyze, descriptive, frequencies, you'll see a screen like this. And here all your variables will be listed on the left, and you can highlight those and pop them over into the variable box, this number 2. And so you can see that I've got almost everything over. I wanted to leave one so that you would see where they were at. So pop the variables that you want descriptives on over into the variable box. And then click this little statistics button. So that's 2. When you hit the statistics button, you can choose mean. That's one of your measures of central tendency. You could do median and mode and all of those. You can come down and get measures of dispersion, which would be standard deviation, minimum, and maximum. And then you should also click skew and kurtosis. Now, this isn't a stats lesson, but you guys probably know that the mean is the average of all the scores. It is a rough index of how the sample or how that group is performing. Maybe nobody actually has the mean score, but at least it's a dirty estimate of how people are doing. That standard deviation, that measure of dispersion, is a measure of how good that mean estimate is. If we've got an IQ score with a mean of 100 and a standard deviation of 15, it means average is somewhere between 85 and 115. that may not sound very precise because that's a sort of a big standard deviation. Minimum and maximums are nice to have. It's a good way for you to check whether your data are clean or have those kinds of errors. And then skew and kurtosis are two other measures of the distribution. Skew is whether the bulk or the largest part of the scores are in the center, which we'd like them to be for a normal distribution, or whether they're off to the left on the low end or off to the right on the high end of the distribution. So skew is really that where the big bump in the distribution is. Kurtosis is how sharp or gradual the curve or the bell curve is. And so we also want sort of a normal kurtosis if there are long tails or if there are sharp peaks that can cause problems when we run parametric statistics. So we want our means, our standard deviations, our skew, and our kurtosis to be within normal ranges. When we see some output, I'll talk about SPSS and its algorithm for normal. All right, so we've popped variables over. We've put them into the variable box and hit statistics. We've requested means and standard deviation and minimum and maximum and skew and kurtosis. Now we're going to hit continue. And we're going to come back to this screen. You might want to unclick the display frequency. If it's got a check mark in it, just click that box. And then we can go ahead and hit OK. What we've done is we've told SPSS we want to run a mean, standard deviation, minimum, maximum, skew, and kurtosis on all the variables that we listed in that box. We don't have to see all the details. We've told it what we want. And then we've clicked that OK button. When you click the OK button, SPSS should take you directly to the output menu or the output file. And so hopefully if you're working through, you've done that. And we can learn a lot from looking at this output. Like here we see that we have 5 cases that gave us their age. 4 people gave us their sex. We have IQ scores on 5 folks. And we have 5 valid scores for the other 3 measures. And then of course the number of missing should correspond. We know we have 5 people in the sample, so that works. Average age in our sample, 22.2. With a minimum and maximum from 21 to 23. If you go to the next column and you look at sex, now Qualtrics had it coded 1, 2, and 3. But I've already done a recode to 0 and 1. My convention for variables that, for gender, for example, I may code females as 0 and men as 1, and non-binary, I'll come back to that. Non-binary I may code as also as 0 or as a -1. Because what I want to be able to do is to look at this mean and say something about my sample. And so in this case, we know that we had 2 0s and 2 1s. And so I can say, oh, 50% of the sample reported being male. In most of our samples, in most of my lab samples, we don't have a lot of non-binary individuals because our sample sizes tend to be, 200, 300, 500. So we're just not, and I do middle-aged and older adults. So I'm just not getting a sufficient number of individuals who are non-binary to analyze meaningfully. And so, some areas of research can do those really fascinating analyses and some can't. So, know your discipline and know the limits of your sample. If I was going to do some analyses that really focused on self-identified sex, and I had one person who was non-binary in a sample of 400, I probably couldn't include them because, I'd only be analyzing one data point. So you have to understand the spread of your data as well. So if you look at the IQ column, which I've done in red for you, it's a scale, as I said. Most IQ scales have an average score of 100, standard deviation of 15. In our sample of 5 folks, we've got an average score of 112, but our standard deviation is just about 8. So it's not quite a normal distribution for IQ. And when we look down, we can see it's a pretty tight range. Well, if these are college kids who are, you know, towards the end of their degree, they probably do represent the higher end of average or the normal range. So I'm not overly concerned. But the skew is a little bit off. For SPSS, for this version of SPSS, and really any in the last 10 years, scores for skew that are greater than absolute value of +1 or -1 have a problem. And so we really do want our skew to be 0 or thereabouts. And so we would probably want to follow up by looking at this distribution a little more carefully, and we will. If you look at the skew and kurtosis for some of these other variables, you can see the kurtosis for research is hard is awful. I mean, it's a -3. Kurtosis also has a -1, +1 is bad. So we really want close to 0 for our kurtosis measure as well. And so you can see that this is, it's really spiked. Because it's an individual item, we might not care too much, but we would want to look at that when we combine it in a scale to see whether or not it's causing problems in the way that scale acts. Here, for a number of days per month that a person spends with their friends, it's got a spike. That's what that kurtosis indicates to us. And if you look, it's like, well, yeah, we've got a really wide range. We've got 6 to 25, an average, you know, of about 14. We can see that 25 is really up there. So you can look at your data and say, well, there, you know, if that had been 52 days in the month, we would have said, you know, there's an error. But we can at least pay attention to these data may not be perfect to enter into some of our parametric statistics. So if we're concerned about the distribution of IQ, we might want to look at it. And so we're still doing the exploratory data analysis, and so this is a fine way to get a feel for your data to be cozy. And you can get distributions of variables in SPSS pretty easily. You can go analyze, descriptive, frequency, just like we did before. You can keep all the variables in that box if you like, or you can just do IQ, whatever's fine for you. And then you're going to click the statistics button. And remember, this is where we did mean, standard deviation, skew, and kurtosis. If you click statistics is where we got the mean. If you're doing analyze descriptive frequencies, go ahead and click the charts button, and that's where we can get some of these graphic displays of our data. If you're stuck in the statistics button because I misspoke, just hit the OK or the continue, and you can pop right back out here to where you can choose charts. So analyze descriptive frequencies, charts. Under charts, you've got some choices. You can do bar charts, you can do pie charts. We're going to do a histogram, which is that normal curve, and we're going to ask SPSS to actually impose the curve on top of that so that we can evaluate it. Go ahead and hit continue. It'll take you back to this page and hit OK. And when you hit OK, it will pop us back out to the output. And you can see that it's a pretty awful distribution. We have an average score of 112. We knew that. A standard deviation right around 8. We knew that. And it looks like we've got that one low average score, and we've got sort of a little bump towards the higher end of average. If this were our dependent variable, if this was what we were trying to predict, we might be really worried about this distribution. If we're just using it as a covariate or as a descriptive variable, we might be okay. But we would never do a study with just 5 people and report statistics. So hopefully if we had a bigger sample, this would be a better distribution. All right, let's see how you guys are doing in terms of questions. Anybody have any questions that you want to ask? I feel like I went through that pretty quickly, although we might be on time. That's all right. Let's hear your advanced question. Feel free to unmute yourself or to type.
Yes. Hello. How you
Hi.
doing?
Good.
Thank you for doing this. We truly appreciate that.
Thank you.
Yeah, I don't want to take anybody's time, but I do have a question on how to implement ANOVA with related measures. I'm working on my proposal and all that, but I've been having issues with implementing that on SPSS. So I'm not sure whether you're going to get to that point or not. I'm just throwing this out there, but I'm going to be here no matter what you do.
I am going to do ANOVAs in a few minutes, but tell me specifically what kind of ANOVA, and I'll work your example in.
So this is going to be, well, I guess I have to also explain. I have two factors in this experiment. One has three levels and one has 2 levels. So I assume this is going to be N-way ANOVA with related samples.
Okay.
Independent samples.
Okay, we will.
This is where I am getting so confused.
Yeah, I'm happy to, when we get to that, because I think we're going to have some extra time, and we'll walk through some of the factorial ANOVAs. So thanks for giving me the heads up so I can think about that.
Thank you so much. Okay.
No problem.
I'll stick around. I'll be here.
Okay, well, it's coming up. Anybody else? All right.
And may I say something? I'm not sure. I missed the first few minutes. SPSS is obviously expensive and everything, but there is a website that offers 6 months of SPSS. It's called the Complete Grad Pack, and it's like $34 for 6 months.
Correct. And you can go, besides the free download that's got the link here, WVU has some packages that you can do through them. So, I mean, I don't have the right to spend other people's money, but sometimes departments, programs, faculty may have a few extra dollars, and sometimes they might gift their grad students.
I could not do it in my department. I'm in the computer science department, so I ended up buying my own, but it's only $35 for 6 months.
Oh, that's nice. Yeah, and it is a pain to have to renew it. And usually they keep them going for like another 5 or 6 weeks, so it's not like the day of your license dies. But thank you for sharing that. So $35 seems like a good investment for your training, especially if you're finishing up a dissertation or a thesis.
Absolutely. All right.
Thanks for that. Okay, then I'm going to move back into this. But again, feel free to put something in the chat or to unmute yourself. So we've talked a little bit about entering data, running some descriptive statistics to look at means and standard deviations. Most of us, at least in the social sciences, when we ask a bunch of questions, we don't really just want to look at a single response. We do want to combine them into scales. And we have those 2 little questions on our sample about, research is hard and I love science. And so we might be able to combine those 2 into something meaningful. And so we're going to spend a few minutes talking about recoding variables and other kinds of transformations, including creating scales. So there's a lot happening on the screen. But again, if you've got the research is hard and the I love science questions, if you look at those, you can see that they probably relate to each other, but the coding is different. Like research is hard. If somebody agrees with that, they probably don't love science. And so, but so the agree for research is hard is a 1. I love science is disagree. If that's a 3, those don't combine well. And so we need to make decisions whether we want to combine our items to create a scale that's about research liking or research disliking, because one of these items is going to have to be recoded. I've just arbitrarily chosen research, a positive research science kind of scale. And so we're going to talk about how to reverse code at least one of those items. So to reverse code the items, you go to transform. And then you've got some choices. You can recode it into the same variable or recode it into different variables. We're going to recode into different variables. And Nima, go ahead.
So the menus that you show, are they on the output window or the main window?
Should
Is
be,
there any
oh, on the,
difference?
yeah, on the, go back to the data file. Thank you for, so if you're still stuck in the output file, go to the window icon or the window link at the top of the screen. Do you see a
Okay.
window?
I mean,
And
is there
then,
any difference if you do these changes and menus in the output window or the main window?
no, not really. Not in this version of SPSS, but they, you know, so it's wherever you're comfortable. Some people just like always going back to the data screen
Okay.
because it's easy to get lost in the output screens.
Okay. Thank you.
Sure, thank you. Okay, so we've got transform, recode into same, or recode into different. If you recode into the same variable, it can, you have to leave yourself excellent breadcrumbs that you've done that. Because there's nothing in SPSS to tell you ever that that's what you've done. And because mistakes are easy to make, I almost never recode into the same variables. I always recode into different variables so that there's a strong record. So I like to go transform, recode into different variables, and then it will open up a box like this where you can see your variable list. And you're going to choose a variable. And so if you're working with me, click on the Q5B, just highlight it with your cursor, and hit the little arrow here to pop it over into this numeric box. And SPSS is going to ask you to give this variable its new name. And so here's some naming conventions that you know, lots of us use. So this original variable is Q5B. It's the I love science where agree is low and we want agree to be high. And so we're going to call this new variable Q5B underscore R because R means recoded. Sometimes people will use an X at the end of a variable name, but they do something that makes it pop out that this is a changed variable. And then besides typing in that new name, they'll probably give it a label that's really clear to them that, oh, this is that science item, they like it, it's been recoded. And then you can hit change and that should pop up into that box. So we've chosen the variable we want to recode, we've popped it over into this box, we've given it a new name, and we've given it a new label, and we've hit the change button. And then, it's a bad edit, I apologize, there's an old and new values button. And if you go ahead and click that old and new values button, here's where you can tell SPSS that you want to reverse code it. And so here you just literally type in old value 1, new becomes new value 3, and you hit the add, and it'll just pop into this dialog box. So we want 1s to be 3s. 2s are going to stay the same, so you could type 2 goes to 2, or 2 copy old values, add, and then you want to do the 3s go to 1. So you have to do each variable, or each value, excuse me. So if it was a 1 to 5 scale, you'd go 1 to 5, 2 to 4, 3 to 3, 4 to 2, 5 to 1. The reason that I go ahead and type in 2 to 2 is because then I can really easily look at this list and I can see that I've got all the numbers accounted for and correctly. I'm a horrible typist. The older I get, or maybe the busier I get, the worse I get in my typing. I need every one of these visual backups to make sure that I haven't made a mistake. So you can tell SPSS right here how to recode the variable, and you can hit continue, and it will take you back to this page. And there's 2 things you can do here. So if you're following along, just listen first and then make a choice. So 2 things you can do. You can hit the OK button and SPSS will do what you just asked it to do. Or you can hit the paste button and SPSS will take all of that code and paste it into a syntax file. And so if you hit OK, oops, sorry about that. if you hit OK, it changes the variable. If you hit paste, it opens up a new document or a new window. And this is super nice. Always paste your transformations. It's a record of what you've done to your data. And often the SPSS file is timed or dated so that you can know when you did these things. Nima, do you have a question now? Or did I just not undo you?
Sorry, I just forgot to.
No
raise my
problem.
hand.
No problem. So here's a horror story. So my first, I don't know if it's, my first PhD student had some data transformations that she was doing, and like the first 100 people came into her study and she ran the transformations, yay! And she was changing all the 2s to 1s and all the 1s to 0. And then she got another 100 cases in and she entered them in the file and she ran the recode so that all the 2s became 1s and all the 1s became 0s. And then she found that everybody had a score of 0 because she had already run the recode from 1 to 2 to make them into 1s and 0s. And then she recoded all those 1s again. And so we had to really go back and redo those variables. So you do want to be really careful about when you apply these kinds of recodes. If you're doing it as data are rolling in, you run the risk of overwriting your own data and losing those variables. So pay attention to when you do your recodes. Some people maintain 2 separate files, one that has data that have been recoded and one that's just the raw data that they never, they just save differently. So they keep their raw data separate from the transformed or recoded data. Talk to your faculty mentor, see what their lab likes to do, see what happens in your field. I mean, there are different shortcuts that different disciplines use, so feel free to, to find that stuff out. Okay, so if you hit the syntax button, you've got this file that says dataset recode, it says something like this, but you haven't made that change yet. There are a couple of ways that you can do that change, but both of them involve you highlighting this text, which I can't do because this is a PowerPoint slide. But you would just highlight this whole command, and then you can either hit this green go triangle, or you can hit the run button. But most people just use that green triangle. So you can just highlight, hit that green button, and now your changes have taken place. So wherever you're at, if you've done it from syntax and you've hit this green button, or if you were, if you want to go back to the transform recode to different variables, it'll take you right back here, and you can hit OK. Depending on what you've done, SPSS might ask you, do you really want to overwrite this variable? The answer is yes. And so you should have created a new variable. I think we just did this one, sorry. Did we? Oh, we'll come back to that in a second. I do want to show you how you can also, sorry about this, use the syntax to create scales. And so we'll do that. We'll do this 2 ways as well. In the syntax file, you can write statements like compute new variable name, and then tell it to use Q5A and Q5B _R. And that tells it that we want it to take our new transformed variable and the old Q5A and combine them. And so, so we can use this syntax box for lots of things. If you don't want to combine variables in the syntax, you can do it from the drop-down menu pretty easily. You have to get back to the data file itself. So if you're working in the syntax box, you might go Window and then go back to the .save file. And then you can go Transform, Compute. Here it will want you to type in a new name, and then you just use these buttons to tell SPSS what variables go into this new scale. And so just like the syntax that we saw on the last slide, here we're just going to type in or pop over these variables together. You might want to use the parentheses. You don't have to if it's just a couple of variables, but sometimes we want to create variables where we're using more than just addition. You know, we might want to use multiplication or division or something. And so the parentheses help SPSS to read that code correctly. Again, you've got the option to paste it into syntax or just hit the OK button and make it happen. If you go back, I think I'm missing a slide. I apologize for this. Yeah, I meant to show you what that looked like. If you go back to your data file and you've done these transformations, you should see definitely a Q5B underscore R that you just created, that instead of being agree as 1 and disagree as 3, you've just reverse coded that. And if you created the scale, you'll see a new column that says, you know, science underscore attitude or something like that. And so SPSS will add to your data file for you. When you're ready to end, of course, you have to hit your save icon, whether that's the little old-fashioned diskette or whether you actually do file save. But it won't automatically save these new variables. You have to tell it to save those. SPSS will do some standardized variables for you. And so if there are times that you need to use z-scores for your data. We talked a little bit about skew and kurtosis. If you've got data that are poorly distributed, that don't meet the underlying assumptions of parametric statistics, you might need to use these z-scores. And SPSS will compute those for you. If you need z-scores, you can trick those out by going Analyze, Descriptive, and then come back over to Descriptive. So it's Analyze, Descriptive Statistics, Descriptives. And then you just pop in the variable that you want to be converted from its current scale to a standardized z-score. And you might recall that we're going to do days social because it had some weird kurtosis. And so that's a good option for a z-score. So if you do Analyze, Descriptive, pop days social over into here, and then you click the Save Standardized Value and click OK, SPSS will add that as a row, or excuse me, as a column. And now each person has a z-score for days social as well. Again, you want to save it, but it's a nice way to do z-scores if you need those. Okay, so a little bit about, you know, how to manipulate some of these transformations. We're going to start to talk a little bit about some specific analyses. Almost everybody, after running means and standard deviations, wants to run some level of correlational analyses. And SPSS actually has quite a few options available. So if you're working in the data file, you can go Analyze, Correlate, and you should see a box. If you've got some options here off to the side. You've got bivariate, partial, canonical correlation. We're just going to work with bivariate today. So if you go Analyze, Correlate, Bivariate, it should open up a box like this, and all of our variable names should be on the far left. And you can just choose the variables you want and pop them over into the box. Go ahead and hit, we've got options, style, and bootstrap. Go ahead and hit the options button just so that you can see what's in there. Oops. We've got some means and standard deviations that we can request. If you're creating variance covariance matrices, you can do that here. You've also got the option of asking SPSS to include every case that has a valid measure or a valid score on that variable, or to just include everybody. So think back to our variables. We had 5 scores on age for the 5 people, but for sex we only had 4 valid scores out of the 5 people. If you click the pairwise selection, you're gonna get all the people in each analysis except for sex. And on the sex, you'll only have people who gave valid scores. If you click the exclude cases based on listwise deletion, you're only going to get all 4 people who gave answers to all the questions. And so that person who's missing gender, they're never going to be in your analyses if you do list-wise. There may be times that that's appropriate. For most of what I do in my research, although it's annoying to see a correlation with 100 for this pair and 98 for this pair, for the most part, I go ahead and report those pairwise with the unequal n because that seems truer to the data. But your discipline or your question may be different, and that's fine. All right, so at this point, we've got, you can go ahead and hit continue. In the variable box, go ahead and do age and sex and IQ and days social. And if you have the science attitude variable, go ahead and do that. And then we'll hit this OK. Oh, okay, well, actually, I want you to do this. So if you hit OK, go ahead and go analyze, correlate by variate. Come back to this screen. We've got a couple of different kinds of correlations that we can request. The Pearson is by default the one that's there. There's also Kendall's tau, which we don't, in psych, we don't use it very often. It's for variables that were both are measured on like a categorical level. And then we've got Spearman that we can use with the variables like gender that are categorical or race that are categorical. And we want to correlate those perhaps with age, which is continuous. So if you just make sure you've got Pearson and Spearman clicked and then go ahead and hit OK, we can go to the output. So because we asked for it, the output gives us both the Pearson and the Spearman correlation coefficients, but in 2 different tables. If you were to do a partial correlation, which was another request, you'd get your 0 order correlations, these Pearsons, and then you'd get correlations with some third variable sort of partialed out. Here, looking at the Pearson, we've got, if age correlates, a correlation coefficient of 1.0 with age, of course. We probably shouldn't use a Pearson correlation coefficient with sex because it's dichotomous and age, but it's pretty similar in this case. And we've got IQ and age has a Pearson correlation equal to -0.30. You guys know that the closer a correlation coefficient is to positive or -1, the stronger the relation. There are different rules of thumb. Cohen is often cited as giving rules of thumb that correlations that are between 0 and the absolute value of 0.2 are minimal. 0.2 to 0.4 might be small. 0.4 to 0.6 might be moderate. 0.6 to 0.8 are strong, and anything over 0.8 is near perfect, so it may not actually tell you much. So we look at a correlation of -0.3 with age. It's like, well, that's on the low side of medium. It's not ignorable. There's something there, even though our age range was 21 to 23. We've got evidence from the correlation that the younger people in our sample are spending more days per month with their friends because it's a -0.7 correlation. That's pretty strong. When you look at the significance level, you can see none of these correlation coefficients are less than 0.05. None of them are statistically significant because we've got 5 cases. It's really hard for a significant correlation to come out. But when we come down here and we look at the Pearson correlation coefficient between IQ and science attitudes, we have a coefficient of 0.916, which is significant at the 0.05 level. I wouldn't get terribly excited about that because I made up these data, and so I wanted something to come out. And so I, said, oh yeah, science. People who love science probably have higher IQs, and so that may or may not be reality. But since we're all here, we can imagine that might be true. So when you run your correlations, you really should look at them. Look at the magnitude. Look at the direction. Look at the sample size. And a correlation of 0.92 is big, even if it's not, well, this in case it is statistically significant, but here the -0.73 is big, even though it's not statistically significant. So, you want to be able to balance the size of the correlation with the sample size. And you guys would probably never run correlations with 5 cases. Okay, so we've run some descriptives, we've run some basic correlations. I do want to talk a little bit about some other sort of basic statistics that you can get out of SPSS. We're not going to go through all of these. We're just not. But we can run some differences between group means, and there's a slew of ways to do that. We can also look at differences among constructs, which I'll talk about more, or we can talk about relations in a variable set. So just so that you have a sense of where we're going. I'm going to stop for a second in case there are questions in the chat. Yeah, always keep a copy of that raw data no matter what you do. Absolutely, because life is hard. Anybody want to unmute and ask anything before we dive into inferentials?
Yeah, I have a question.
Great.
So about what you just did, so those high correlation between parameters, I mean, just to make more sense, does that mean those parameters have a linear relationship? Is that right?
Well, the Pearson correlation does say that it's a linear association. But the thing is, unless you've done good descriptives, you don't know that that's true. It doesn't tell you that there's a curvilinear association. So,
Okay.
you know, you really do need to look at those descriptive data, look at the spread. Yeah, that's a great observation.
And I mean, compared to what we see in Excel, if we draw a trend line, does that mean that the R square is very close to 1? If the correlation numbers are close to 1, are they
Yes.
comparable?
Yes. And actually the R, you know, for that trend line, if you take the correlation coefficient and you square it, that is the R square trend line. So.
Okay. And I have a more general question as well. So every time I do something in the SPSS, any operations, a new window pops up. So sometimes it's output, sometimes it's a syntax window, and they are not saved. So do I have to save them all the time? Or if I close them, I will miss all of what I've done?
If you close them without saving, it's gone forever.
Okay, so I have to keep the output window open, so not every time having a new output.
Right. You can keep it open and just do a running total of your output,
Okay.
and then save. You know, hit the save icon every so often.
Okay. All right. Thank you.
Sure. Anybody else? All right then. Well, again, feel free to unmute or jump in. I can't see the chat box when the screen share is on, so feel free to unmute if you need to. All right, so, we're good on time. All right, so mean comparisons. SPSS does a variety of comparisons of group means, and you can get there a couple of, well, you can get several different analyses by going analyze, compare means, and then you can see you can run means tests, one sample t-tests, independent samples t-tests, paired samples, and a one-way ANOVA. If you're doing, just so that you know, because sometimes people don't know what these different tests are, in my lab we use one sample t-tests in almost every single paper because we do these older adults, many of them are from West Virginia, and the average education for our older West Virginians is about 12 years. And journal editors have stereotypes. You guys know, journal editors have stereotypes. And so we've gotten comments back, oh, you must not be getting average older adults because they've got a high school education and you're from West Virginia. And so we've just started using census data to say, the average education in our sample is 12.2 years. We ran an independent samples t-test with that 12.2 years against the census average, and there's no difference. So an independent or a one sample t-test allows you to compare your group mean to some standard. And so our lab, we use the census test. And so that's if you have people that are haters. That's a way that you can, in your paper, show that your sample is indeed representative of whatever group you're trying to capture. We'll talk about independent samples t-tests in a second. Paired samples t-tests are the ones where if you've got people, 100 people in your sample, and they did a measure of optimism and a measure of pessimism, and you can get those scales the same. You can get optimism and pessimism on the same measurement scale. You might ask the question, are people more optimistic than they are pessimistic? And so the paired samples t-test allows you to compare people, the same person, on different scores. We have some longitudinal data where we have ageism before the COVID outbreak, a month into it, 6 weeks into it, 8 weeks into it. And so we're tracking people's ageism across the pandemic, and we can do paired t-tests at each wave of data collection to see whether or not a person has changed from time 1 to time 2. So for those of you who are doing multiple measures of the same people over time, paired samples t-tests might be one way to get a snapshot. And then one way ANOVAs might be a case where you've got different samples or different categories that you want to measure people on. All right, so we're going to do an independent samples t-test. You guys know these. It's when we compare young and old on some measure, or men and women on some measure. And so if we've got a dichotomous variable that we can compare groups on, we can go analyze, compare means, independent samples t-test. And then we have to tell SPSS a bunch of stuff. We have to tell it what variable we want to measure. And so we might want to compare people on days social. We have to choose the grouping variable. And so for this example, I'm just going to use sex. And so you would choose sex out of this box and pop it under a grouping variable. And that will open up a define groups dialog menu, or if it doesn't, you can hit the define groups. And SPSS wants you to tell it the category values to compare. And you're thinking it's sex, so I've got zeros and ones. But if you've got age, and maybe you've got age groups, or maybe you've got different, maybe you've got men, women, and non-binary. If we had enough individuals, we could say, well, let's compare the men to the non-binaries, or let's compare the women to the non-binaries. So you can use, you can compare any two groups under that grouping variable, which is super cool. And so we're going to compare, because we just have men and women in the sample. That's our group variable. We're going to compare them on the number of days that they're social each month. We can exclude cases by analysis. You know, I just wanted you to see that there's options that you can choose. Go ahead and hit continue, hit OK. It will take you to the output, and you can see we've got data for 2 women and data for 2 men. And the average number of days that women said they socialized was 22. Average number of days that men say they socialized a month was 6.5. Standard deviations are very different. Ordinarily, if we had any decent sample size, we would have numbers here. And this Levine's test tells you whether those standard deviations are comparable. And you can look at those as scholars and say, it's unlikely that a 4.2 standard deviation for women and a 0.7 standard deviation for men are comparable. But because we've got such a low sample size, it won't run the Levine's test for us. If your Levine's test is significant, you have to use the second line of data to report your t-test. If your standard deviations and variances are equivalent, then you get to use the top line. And so we're going to assume that they're equivalent because we have no other data. And so we can see that we've got a t-value equal to 5.096 with 2 degrees of freedom, and it's significant at 0.036. So we've got a significant difference between men and women on the number of days they spend with friends, and it's significant at the 0.05 level. And we can look at the means and see that women report more days than men. And so that's our t-test. Significant group difference between men and women on the number of days that they socialize. And again, I just made these data up. We can also go analyze, compare means ANOVA, and we could do a one-way ANOVA, and that's what this, I think that's where I'm at here. And so we've got a dependent variable on science attitude. We can have a fixed factor of sex. We've got, you know, data on men and women. If I had age groups, I could put an age group in here, younger, middle-aged, older. If I didn't have age as a group, I could pop it down here as a covariate. So there's lots of different things that you can do here. We can choose a lot of specifics about the model, but what I wanted to show you here is under the post hocs. And so you can ask SPSS to run a means test on each level of your fixed factor. Now, sex only has 2 levels for us right now, men and women. But if you were to ask for post hocs, you could ask for a whole bunch of statistics here. You could get a Bonferroni, a Chaffee's test, a least significant difference. And so different disciplines have different post hoc tests they love. Find out what your discipline uses and report that one. Most disciplines want to see at least 2 post hoc tests and have them agree. And you're going to learn what your discipline likes, one, by asking, but also by reading the science in your discipline. So you'll see that, oh, they never mention the Chaffee's. They always talk about the least significant difference. Or, you know, everybody loves Tukey's test. And so you'll pick up on those things. So you can ask for those post hoc tests. You can hit OK or continue. You can come back to this menu and hit OK. And this will give you the F test for whether there are sex differences in science attitudes. We had a sex difference in the number of days people were social from the t-test. When we run this particular factorial ANOVA, we see that we get an F with 1 degree of freedom for the corrected total, the corrected model, and 3. So the degrees of freedom are 1 and 3. And the value of that F is a 1.0, and it's clearly not significant. And you might say, oh, but the one above it is. Well, that one above is the intercept, and that's really just asking, are the means on science attitude in the sample different from 0? So yeah, we do have, you know, we have real scores here, but we don't care about that. We knew we did. But we don't have a gender difference or a sex difference on science attitudes. So factorial ANOVAs. If you wanted to run a different kind of ANOVA where you've got a mixed ANOVA or a factorial ANOVA with different variables, you could go analyze. I think it's generalized. Ooh, because it's not in front of me. I would definitely get back to you. I think it's generalized. Oh, I don't know. Because I don't have it open. Let me see if I can find it on this screen. Oh, general linear model. There you go. So you would go analyze general linear model. And that will open up a new screen for factorial ANOVAs where you could do a gender, maybe a 2, which is a between subjects variable. And then maybe you've got a whole bunch of within subjects variables. Maybe you've got, I don't know, mood, optimism and pessimism. And so that would be a 2-factor within subject. Or maybe you've measured that over time. And so you can set these up so that you can do both between and within. It is a little bit tricky and you do want to think through it. I'm happy to get on a Zoom call separately with anybody who wants to do that. That's what we're doing for our ageism paper. We've actually looked at time and type of ageism within subject, and then we've looked at age as another between subjects variable. And so there's a lot going on there, and we can measure young adults and older adults ages, positive ageism and negative ageism over 6 times. And we can do all that in one single analysis. So if that's the kind of ANOVA you're looking for, reach out to me and we'll just do it separately so as not to lose the folks. Okay, so Mean differences, you can do a whole bunch with t-tests, a whole variety of t-tests, lots of different kinds of ANOVAs that we can trick out. We're going to talk ever so briefly about regressions just because I want you to know how to set them up. And again, I teach well, I don't have to teach it anymore. I teach different classes now. But for like 14 years, I taught the first year graduate regression course in psychology. And so, I mean, it was a 16-week course, so we're not going to do it all in 2 minutes here. But if you just need some basic, what buttons do I push? You go analyze regression. If you're just trying to explain just trying to explain variance in a dependent variable, you'll probably want to use a linear regression. Some of you may be having outcome variables that are dichotomous, alive or dead, addicted, not addicted. Those are probably going to be your binary logistic regressions. Some others of you may have 3 categories of outcomes, obese, normal weight, underweight. And so if you've got a 2-category outcome, you can use the binary logistic. If you have 3 or more, you can use the multinomial logistic regression. If you have experimental outcomes, probit analysis is your way to go. Excuse me, but we're going to use a linear regression today to predict variance. So we're going to go analyze regression linear. And we're going to try to predict attitudes about science. Remember, the I love science and research is hard. And so we've done a little bit with this data set. So we have a sense of how these should come out. If we plunk over the science attitudes as our dependent variable, we can choose, I don't know, anything we want, but we can choose IQ and number of days of being social. And here's my stereotype. So people who love science are going to be smart, and they're going to be stay at home. And so they're not the social butterflies. So I expect high IQ and fewer days of social to predict positive science attitudes. Okay, so we set up our dependent variable and our independent variables. We can go ahead and click the statistics button, and you can see that a bunch of options pop up there. For ease, we're just going to click regression estimates. Ordinarily, we'd do confidence intervals, but we're not doing it today. Model fit, R-square, and descriptives. Ordinarily, we would also do all of these diagnostics, but again, you know, you guys don't want to get into that right now. But there's some really nifty diagnostics that you can make sure that you don't have a single data point that's really pulling your regression line. So estimates, model fit, R-square, descriptives. Hit the continue button. Come out here and hit the OK button, and that will take us to our output. And so here we've got a lot of stuff that we're looking at. Come down to the model summary in the output, and you can see that we've got an F test with 2 and 2 degrees of freedom. Excuse me, I don't know what that, we've got 2, we're going to pull this from here, 2 and 4 degrees of freedom for the ANOVA. It's equal to 5.45, but it's not significant. With 5 participants, it's hard to get a significant finding. So we have a non-significant equation. So according to this, IQ and days of social doesn't predict a statistically significant amount of variance in science attitudes. But when we look at our R-square, which is the amount of variance that our equation predicts, we're getting 84.5% of the variance in science attitudes. So that's a bunch. In psych, if we get an R-square value of 0.3, we're ecstatic. If we get a 0.5, we're like, look out, Nobel Prize, here I come. We don't get huge R-square values. So this is amazing. It's telling us that we're getting, you know, almost all of the variance that exists in science attitudes. But for some reason, it's not coming out statistically significant. Well, it's because we've got 4 or 5 people in our sample. Ordinarily, we would stop interpreting this regression equation here, and we would just write it up that the F with 2 and 4 degrees of freedom equaled 5.45, P is equal to 0.155, R square is equal to 0.845. if it were significant, you'd want to report those standardized betas. And so I wanted to at least draw your attention to those as well. If you're doing a regression, you probably want to report standardized betas. Here, a standardized beta takes the variables in your equation and puts them all on the same scale so that you can compare which one is more important in predicting variance in the outcome. And so the bigger the beta, plus or negative, the stronger a predictor it is. And so when we look at IQ, it's like, oh my gosh, you know, that standardized beta can only go up to 1.0, and IQ is like a 0.96. That's huge. That's a big, strong beta. Number of days of social is a negative 0.08, so that's really practically zero. So even though it's not statistically significant, the beta weights tell us that relative to each other, IQ is what's carrying the story here, that number of days social doesn't matter at all. And so if you were running an analysis predicting something else, depression, maybe you had age and gender, if age had a beta of 0.96 and gender had a beta of negative 0.08, you'd say, wow, age is really an important predictor of depression. In this case, IQ is an important predictor of science attitudes. All right, so there's a bunch of tutorials. I think sometimes students are hesitant to use tutorials, but SPSS has some really nice resources. They used to be directly embedded and easy to get to, but they're less easy to get to. But you can go to their website, the IBM website, and you can use the statistics coach. And basically, if you get into that tutorial, it will ask you questions like, well, what kind of data do you have? What kind of question are you asking? And you can say, oh, I just descriptive. And so then it will give you all, you know, it'll say, well, are you trying to compare two groups? And you can say yes or no. And so it takes you through this decision tree, and then it will give you, well, here's some suggestions on some statistics you should run. And then it'll link you to, here's an example of how to do it. And so it really is like having somebody sitting at your shoulder telling you, you know, if these are the questions you want to ask and answer, this is the way to go about it. This is the way I still learn new statistical techniques. And so I always encourage my students to walk through the examples. I mean, they're really good. If you're not somebody who likes to walk through examples and really, you know, dive deep, Andy Field might be your speed. Andy Field is off-putting to some people, hysterical to others. And so he is a little bit irreverent. He will sometimes use mild profanity, and his examples are always a little bit on the edge. But you might look him up under YouTube, and his explanation of how to do statistics, both the buttons to push, but also how to interpret, are really accessible. If you're a little bit, if Andy Field seems a little bit too much like fraternity sorority statistics for you, Patrick Curran might be really good too. Patrick is brilliant and is just a master teacher. And so his style is very different than Andy Field, but it's equally good. And Curran is very sophisticated. Field is very basic statistics. So a couple of resources for you as you work through. I'm going to leave this up for a second so that you can get down my email, but also Dr. May would greatly appreciate if you would complete the evaluation. So I want to leave that up there for you for a bit. And this would be a good time if you've got questions or comments. I'd be delighted to answer them.
Yeah, as you are formulating your questions, I would really appreciate if you would it won't take you more than 3 minutes to complete our 10-question evaluation form. This way it will help us to know whether we need to have a follow-up workshop on SPSS or any other topic. We'll be glad to do that for you. And thank you, Dr. Patrick. I'm not closing out yet. I still will let students ask questions here, but I would really appreciate your filling out the evaluation form.
And my offer to talk with you one-on-one is really very sincere. I mean, feel free to shoot me a message. I don't mind consulting. I recognize that people have different resources available to them, and I'm happy to be a resource to you. I just can't find that chat. Oh, here we go. Paste the links here for the tutorials and the evaluation. Oh, yes, I think I can do that. What a great idea. All right, then I'm going to stop sharing the screen, and I'm going to put that in the, as I babble through, put those links in the chat room. Thank you for that suggestion. I told you guys I'm still learning. Sorry, I feel like there's a lot of dead space there. All right, here's the evaluation. Thank you for suggesting that. And I'm going to put my email there just in case. I don't know if that'll work that way, but it might be easier for you to see or copy yourself. All right, any other questions? I really am happy to work through.
Hello again.
Hi.
Thank you so much. I'm definitely going to take you up on that one-to-one meeting.
Good, great, thank you.
Yeah, I'll shoot you an email. We can or organize that. I did have a, like, I guess it's related to ANOVA in terms of I know how to create the residuals and the QQ plots, but it's still, I'm still having issues exactly understanding how to implement those. So I guess I'll save everybody some time and we can discuss this one-on-one. I'm not sure how many computer scientists or engineers are over here, so I don't want to take them into,
Sure.
a different area.
And just because I want other people to know, what I'll do is I will be happy to send you the lecture that I used to give on PP plots and QQ plots, and then we can work through that.
That would be brilliant. Awesome.
Great.
Thank
Sure. So let's see. So somebody's into SEM and multivariate. That would be a great topic. Although, just like some of these, it's hard to do a good structural equation model or path analysis or multivariate webinar. So the more specific you can be in what you would want, maybe they can do a webinar. Or if you've just got a couple of questions, feel free to reach out to me, and I'll see if I can't help you, I'll hook you up. Okay, what was the other resource in addition to Andy Field? Oh, Patrick Curran, sorry about that. I will post that link as well. Let's see if I can grab them all. Thanks for asking that, because as I said, I'm still learning this. It's like, what a great way to share. All right, so here's the statistics coach. Here's the Andy Field is the YouTube. It's a little bit messy. And then Patrick Curran is the last one.
So if there are no further questions, oh, I see that thumbs up. Yes.
Oh, great.
Feel free to leave or stay a little behind. Stay behind so that we could chat if you like. Thank you for joining us today. I hope to see you again in our future workshops. So be looking out for emails coming from us.
Thank you so much for organizing this also. And I got the connections or the contact addresses here, and I might be communicating or be in touch with you for further help. And I really appreciate for this program. And thank you so much and have a great day. Thank you.
Thanks, you too.
Thank you very much.
Maybe I should have mentioned this earlier too. This is also for other students. I use Tableau. I don't know whether anybody else uses Tableau, but it's a very good tool for data visualization. It helps you a lot.
Do you know price? Is that free or?
It's free for WVU students.
Nice.
Yeah, it's Table AAU. I used to give workshops in this, and I give 2 workshops for the economics, and I believe it could be psychology. I really don't know. That was 2 years ago, I think. But it's very handy, Tableau. Instead of having to write some equations to get you a visualization in your data, Tableau does that in literally just like 1 click. The only bad thing about Tableau is that you cannot export charts as EPS to use them in your LaTeX, unfortunately. But that's the only downside of it. It's really, really, really helpful.
Great, thank you.
You're welcome.
Okay, are there any more questions? Let's see, look at the chat box. Okay. If not, then yeah, we're 15 minutes earlier than planned.
Sorry about that.
No,
It's always
that's good. It's Friday afternoon, so it's good. It's good. All right, I'm not seeing or hearing any more questions. Thank you for participating. So Dr. Patrick, thank you very much for your time.
Thank you.
And for sharing your knowledge. I will share evaluation with you once we've gotten those.
Great, thank you so much.
And then I am going to end the meeting.
All right, thank you.
Have a good weekend, everyone.